Hello Seekers, welcome to my channel Science Seekers. Today we are going to discuss another interesting topic, that is oscillatory LC circuit or electrical oscillation. This is the circuit diagram of LC oscillation or LC circuit. Capacitor of capacitance C and carrying a charge Q0 which will be discharged through a coil of inductance is the capital L and the resistance will be negligible. Let here the capacitor of capacitance C and charge of Q0 discharged through a coil of inductance L and the negligible resistance. Here Q be the charge left on the capacitor and I is the discharging current through the inductance. Then the potential difference across the capacitor is Q by capital C and the inductance or induced EMF is the inductance is L whole into di by dt. So the effective EMF in the circuit will be Q by C minus L into di by dt. It must be always 0 since there is no resistance applied in the circuit or LC circuit. Thus QC minus L di by dt equal to 0, where I equal to minus of dq by dt, where I is the current and q is the charge. So qc minus L whole into d by dt of minus dq by dt equal to 0. Here we put the I value, the above equation we get qc minus L d by dt of minus dq by dt equal to 0. So L d square q by dt square plus q by c equal to 0. Then d square q by dt square plus q by lc equal to 0. So d square q by dt square plus omega square q equal to 0. That is the first equation, where omega square equal to 1 by lc. This represents the linear differential equation of second order in LC circuit. Let the solution of the equation will be q equal to a e raised to alpha t, where a and alpha are the arbitrary constant. Differentiating the equation with respect to t, we get dq by dt equal to a alpha e raised to alpha t and d square q by dt square equal to a alpha square e raised to alpha t or e to the power alpha t. Substituting this value d square q by dt square and the q value in the above equation 1, we get a alpha square e raised to alpha t plus ओमेगा स्क्वायर ए ई रेस टू अल्फा टी इक्वल टू 0. इसमें से हम ए ई टू द पावर अल्फा टी को कॉमन ले सकते हैं. ए ई टू द पावर अल्फा टी इज कॉमन एंड रेस्ट टर्म विल बी अल्फा स्क्वायर प्लस ओमेगा स्क्वायर इक्वल टू 0. सो इसको हम राइट साइड में लेके 0 कर सकते हैं. सो अल्फा स्क्वायर प्लस ओमेगा स्क्वायर इक्वल टू 0, देन अल्फा इक्वल टू प्लस और माइनस रूट अंडर माइनस ओमेगा एंड दैट इज प्लस और माइनस आई ओमेगा, where I equal to root under of minus 1 complex number के फॉर्म में. The equation 1 has two solutions. The equations are q equal to a e raised to I omega t and q equal to a e raised to minus I omega t. Hence the general solution will be q equal to a1 e raised to I omega t plus a2 e raised to minus I omega t. That is the equation 2, where a1 and a2 are the new arbitrary constant at an instant of time t equal to 0 and q equal to q naught. So the equation 2 will be reduced to q naught equal to a1 plus a2 because t equal to 0. So q naught equal to a1 plus a2. This is equation 3. Differentiating equation 2, we get I equal to current equal to dq by dt equal to a1 e raised to I omega t into I omega plus a2 e raised to minus I omega t into minus I omega. So at t equal to 0 and I equal to 0, we get the above equation will be reduced to 0 equal to a1 into I omega minus a2 into I omega. So a1 equal to a2. Therefore the equation 3 will be reduced to a1 equal to a2 equal to q naught by 2. Then this above value substitute in equation 2, we get q equal to q naught by 2 into e raised to I omega t plus e raised to minus I omega t. So this will be reduced to in the form of trigonometry. We will reduce that q equal to q naught into cos omega t, because we know that e to the power x plus e to the power minus x by 2 equal to cos x. So this equation will be q equal to q naught cos omega t. This equation 4 represent the discharge of the capacitor, and the period of oscillation is given by t equal to 2 pi by omega equal to 2 pi under root L C, and the frequency of the oscillation is given by f equal to 1 by t. F equal to 1 by t equal to 1 by 2 pi into under root 1 by LC. That is the frequency of the LC oscillator. So that's for today. In further classes, we will discuss about another interesting topic. I hope you all understand the class. For any queries, do comment. If you guys like the video, just like, share and subscribe for more interesting topics in future. See you all in the next class. Thank you.